Continue our study now of rotational dynamics. Here looking at conserved quantities. You know that for translational motion, the momentum of an object is conserved, momentum in a certain direction, if the forces in that direction are zero. So we have something similar conserved for rotational motion in under a certain condition. So let's look at that now. Remember from last time, given an object being acted on by a force, an object at some distance r from the axis of rotation, that force creates a torque. This defines the torque created by the force r cross f. For the force acting at a point. Mass. For an extended object, that torque is I alpha. The torque on an object about some axis of rotation, about some point that given by that defines the moment of inertia, that axis of rotation. This is for an extended body. And you know that translational dynamical equation that is Newton's second. And for rotational dynamics, as we talked about last time, some of the torques, I alpha vector. All right. We also have for translational motion the momentum P mv. And we define this quantity now for rotation, the angular velocity, angular momentum rather, m r cross p for a point mass for an extended body that magnitude is this, where I is the moment of inertia of that body about some axis of rotation. And we can express actually the translational dynamics and rotational in terms of these two quantities. This will be the time derivative of the momentum, some of the forces, some of the torques will be the time derivative of the angular momentum. So that if for the translational motion, you already know, that if there are no external forces acting on the body, then just from this definition, you see that the momentum P is conserved. So if we measure the momentum at two different times, we'll say that P initial is P final. Analogously, for rotational motion, if the net torque on a system, the net torque on a system is 0, then we have that the angular momentum is conserved. So that if we consider the angular momentum at two different times, we can say that L initial equals L final, in case the net torque on the system is 0. So we're a little short on time. Now be sure to look at the next videos. Rover does a 1040 from the text. So see you next time.